Today we're going to be writing equations of parabolas in terms of conics. Our objectives are to be able to write the equation of a parabola in standard form, giving specific information about the parabola and given the general form. So just to remind you, the standard form of parabola comes in two different forms. One, if it's facing up or down where the x value is squared, and two, where it's facing right or left when the y value is squared. Our final answer should look like one of these two forms. So our first two examples, I'm actually going to give you a graph and see if we can work backwards. So if we kind of think about our equation, we don't actually need all of this information to write our equation, but for the first example, I'm going to work backwards and show you how we get all of it. Direction should be easy. It faces up because I can just look and see that. My vertex is this point right here, so it's going to be at 2, -1. The focus I always do as an x, which is at 2, 2. My directrix is this horizontal line at y equals -5. And the focal width I get by counting how wide the parabola is at the focus. Well, this is 6 to the left, 6 to the right, which is a width of 12. Now, which of these pieces of information do I need to actually help me write my equation? Well, the first thing I need to know is what direction does it face, because if it's up-down, it's one equation. If it's left-right, it's another one. So since it's an up-down parabola, I know the x value is squared, and I know the y value will be on the right-hand side. The second piece of information I need is the vertex, because that's what I fill in my parentheses with. Since the 2 goes with the x, I'm going to write x minus 2. And since we have a -1 in the y position, it's going to be y minus a -1 or y plus 1. So the only thing I have left to find is this 4 times p. Now none of these are specifically p, but if I'm given a graph, I just can count how many steps did I move from my vertex to my focus. Well, I went up 1, 2, 3. So I know p equals 3. Because my graph faces up, I know it's a positive 3. So 4 times positive 3 is 12, and I have my equation written. In example 2, I'm just going to concentrate on the three pieces I need. I need to know the direction, the vertex, and our p-value. So can I get that easily from the graph? Well, I know it faces left, and because it faces left, that tells me the p-value is going to be negative. The vertex I can just count is -4, 3, and I can find the p-value by counting. I'm going to go from the vertex. It takes 2 steps to get to the focus, so it's a 2, but since it's left, it's a -2. So now to write my answer, I know it's going to be a left-right, so it's a y. So you have to remember to look at the y value first. It's y minus 3, quantity squared, equal. This is 4 times p. 4 times -2 is -8. And I'm going to do x minus a -4, which is x plus 4. Anytime you write the equation, if you have extra time, always kind of now start here if you feel comfortable and see if you graphed it, would you get the same answer they give you. My next couple of examples, I'm not going to give you every piece of information. I'm going to give you a couple, and you still have to work and figure out the equation. But remember, we need to know the direction, the vertex, and our p-value. In this case, I was only given one of them. So, how could we do this? If you have a hard time visualizing, it's always good to just draw a graph off to the side to kind of plot the points to kind of help you out. So, if I was to graph 0, 3 as my vertex, I'd put it there, and my directrix, x equals -4, would be a vertical line like this. Just seeing that, hopefully now you realize that the direction is going to be right. And now that I know it faces right, I can start to fill in my equation. A right-facing parabola is a y. I'm going to do y minus 3, quantity squared equals. Now, anytime you have a 0 for the vertex, I don't usually write the parentheses. This would technically be like x minus 0. But when we write the standard form, when we write it cleanly, we don't write x minus 0 because it's redundant. You don't really need that, so we just write x. But I didn't need to know what the p-value is. But they didn't give me the focus, and usually I count from the vertex to the focus. But I don't know where it is. It's over here somewhere. But remember that the vertex is equidistant from the focus and the directrix, so whatever distance is here is the same going backwards. So since I moved 1, 2, 3, 4, I know the p-value is 4. And again, we're facing right. That's why I know it's positive. So my final answer, I'm just going to do, remember, is just 4 times p. 4 times +4 is 16. And that would be my final answer. In example number 4, again, now I gave you the focus and directrix, neither of which directly give me any help for my equation. But I'm going to use them, kind of plot it out to kind of help me visually see. I know I have a focus at 3, 6. And again, a focus, I'm going to put an X so I can tell it's a focus. And I have a directrix at y equals -2. Okay. So now I can tell that this faces up. My parabola is going to be in here somewhere. And because it faces up, I know the p-value is positive. But how do I find the vertex? Well, remember the vertex is equidistant from both of these two things. So if I know how far these are apart, which happen to be 8, I know the vertex must be right in the middle. So the vertex now is at the point 3, 2. Well, if that's at 3, 2, that must have meant that I moved a distance of 4, and it's up, so it's positive, for my p-value. So now I can write my equation. It's up, so it's an x squared problem, so it's x minus 3 quantity squared equals, remember this is always 4 times p, well 4 times positive 4 is 16, and then y minus 2. And that would be my final answer. In my last example like this, I give you a little bit weird information. It could be a little bit more difficult. I need again know the direction. I give you the vertex and I give you the p. Well, at least I give you part of the vertex. So how is this going to help me? Well, let's plot some of this stuff. So I know the directrix is x equals 3. And I know that for sure, so I can plot that. And all I know is that somewhere along this line y equals 2, because I know the vertex is at a height of 2, is going to be my vertex, is somewhere along there. So this is actually, since it's perpendicular, is actually my axis of symmetry. But how do I know if it faces left or if it faces right? This p-value is what's going to give me a clue. If p is -6, that means, and again, I should hopefully now know it faces left or right, so I know it's a left or right parabola, I just don't know which one. But since p is negative, wherever my vertex is, I actually have to move left to get my focus, and that's why it's a left problem. Remember, if p is negative, it's left. If p is positive, it faces right. So now I know this parabola faces left. And because I know that, I can start to write my equation. So I know this is going to be a left-right, so it's y minus 2 quantity squared equals, again, this is 4 times p. Well, 4 times -6 is -24. But now I need to figure out what goes with my x. Well, again, along this line, I know I have to move left to get to my vertex, which means, I'm sorry, left for my vertex to get to my focus, which means the directrix must have been to the right. Okay, which means this has to be 6, this has to be 6. So if I'm at my directrix, I can move 1, 2, 3, 4, 5, 6. There's the vertex. 1, 2, 3, 4, 5, 6. There's the focus. Okay, so that all matches up. My vertex, move left 6, which means right 6 was my directrix. So this would have been my graph somewhere in here. Well, since I know that, I now know my vertex is at -3, 3, 2. So that means I'm going to write +3. And that is by far the most challenging one out of the 4 examples we had there. So our last 2 examples go from what we call general form to our more specific standard form. So this deals with completing the square, where we had that plus blank, if you remember that from first semester. So how do we do this? The first thing I would do is look to see which value is squared, because remember in parabolas either the x is squared or the y, not both. So if I look, my x is squared, and we like to have the squared value on the left hand side. So I'm going to keep the x's on the left, and I'm going to put everything else on the right. So if I move this over, it becomes a positive 2y and a negative 13. Most students who make a mistake, they just move this over and don't change the sign, so be careful. Remember, to complete the square, I have to have an imaginary 1 in front of my x squared, which I do. So I can write it as x squared plus 6x plus blank equals 2y minus 13 plus blank. Because if I do something to one side, I have to do the same to the other to keep it as an equation, keep it equal. So this is going to, my goal is to factor this down to something squared, something times itself. And if you remember how that works, half of 6 is 3. And if I have 3 plus 3 is 6, 3 times 3 is 9. If I factored this trinomial, I would get x plus 3 times x plus 3. But I can't add 9 to the left unless I add it to the right. Now the right-hand side becomes 2y minus 4. Now this looks close to what I'm used to. The left-hand side looks nice. I'm used to seeing x plus 3 squared. But the right usually has some sort of parenthesis. Well, what could I factor out? Well, you should factor out a 2. If I factor out a 2 on the right-hand side, I'm left with y minus 2 in my parentheses. Now I can find everything. I know this is an upward-facing parabola that has a vertex at negative 3, positive 2. And even though this is a 2, remember, if I actually asked you to graph this just to show you that not all these numbers work out nice and pretty, 4p equals 2, p would just equal 1/2, which means I'd have to move up 1/2 to get to my focus, down 1/2 for my vertex to get to my directrix. But again, this is all we're looking for in this problem, just doing completing the square. In our last example, I try to make it a little bit tougher for you. It's not that bad. But again, here I see my y is squared, so I'm going to keep the y's on the left-hand side. And here's the 24y. And I'm going to move the x's, 8x over, and the number. So I'm going to get a positive 8x and a positive 16. But remember, I cannot do any sort of completing the square with a number in front of y. So what I'm going to do, and you have two choices here, is I like to divide everything by this value. So I'm going to divide everything I see by 2. Now you could factor it out, which we're going to do later, but right now for parabolas I like to just divide it because it's a little bit easier. So I'm going to be left with y squared plus 12y plus, I can put the blank in now because I know that I don't have a number in front, equals 4x plus 8 plus blank. Half of 12 is positive 6. 6 plus 6 is 12. 6 times 6 is 36. And whatever I do to one side, I have to do to the other. So on the right-hand side, I get 4x plus, if I add those, I get 44. But again, the left-hand side looks like our standard form, but the right-hand side does not. And it would if I factored out a 4. If I factor out a 4, I get 4x plus 11. And now I can tell anything I want. I know this faces right. I know the vertex is negative 11, negative 6. I know the p-value is 1, which means I'm going to move right 1 for the focus from the vertex, and I'm going to move left 1 to get to the directrix from my vertex. And that's how we do completing the square to put it into standard form. I hope you feel a little bit better about writing equations of parabolas, whether I give you some given information about the parabola, or if I give you the general form and ask you to put it into standard form.